And if it's just something you can fix, then just do that. All right, so number 7 starts with a square root function. So the original function is the square, or 3/2 times the square root of x plus 6 plus 2. So the plus 6 means go left 6, the plus 2 means go up 2, and the 3/2 out front means a vertical stretch by a factor of 3/2, because 3/2 is greater than 1. All right, when I think about square root functions, I think about this, and there are no flips, so it definitely goes in that direction. The square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. And then we have this vertical stretch by a factor of 3/2, which means I'm going to multiply the vertical component, 1, 2, and 3, by 1.5 or by 3/2. So 3/2 times 1 is 3/2 or 1.5. 3 divided by 2 times 2 is 3. And 3/2 times 3 is 9/2, which is 4.5. Okay, so I'm gonna figure out my starting point just by using these shifts. So left 6 and up 2. So if we go left 6 and up 2, and then we follow this pattern, we're going to go right 1 and up 1.5. We're going to go right 4, 1, 2, 3, 4, and up 3, 1, 2, 3. And we're going to go right 9 and up 4.5. So from 6, it puts me at 3 and up 4.5. So 1, 2, 3, 4 and a half. And that is my original function. So my original function is the square root with domain from -6 to infinity and range low to high from 2 to infinity. Lowest it goes is positive 2 and then up to infinity. Okay, which means I already know the domain and range of my inverse, so I'm going to write that down. F inverse domain and range. So my domain is going to be the range of my original, so 2 to infinity, and my range is going to be the domain of the original, -6 to infinity. So let's go ahead and start finding the inverse. X equals 3/2 the square root of y plus 6 plus 2. As far as solving for the inverse, I'm going to subtract 2. I guess I should say solving for y. I'm going to multiply by 2/3. So multiply both sides by 2/3. Now, you could distribute the 2/3 and say 4/3, but I'm okay with you leaving it like this here to be able to see the transformation. And that equals the square root of y plus 6. We're going to square both sides. Okay, so I've got 2/3 times x minus 2 quantity squared equals y plus 6, and then the last step would be to subtract the 3. Or sorry, subtract the 6. So I'm just going to go ahead and do that real quick. I'm going to subtract the 6, and that equals my inverse, so I'm going to write f of x, or f inverse of x. But then I'm going to put a comma, because one thing that you have to remember is that if you start with a single square root, not the positive and the negative square root, then you should only end up with half a parabola. This is a full parabola, and so if you say that's my, its domain is all real numbers, but my domain should only be 2 to infinity. Okay? So I'm going to state the transformations, and then we're going to talk about sketching it. So I'm going to go to the right 2 because of that. This is on the interior because it's being raised to second power, so that means it is a horizontal stretch by a factor of 3/2. Remember, on the interior, always flip it. Also, because this is a vertical stretch, this is a horizontal stretch. And then the -6 means go down 6. So I'm going to go to the right 2 and down 6. So the right 2 and down 6. And plot my starting point. So when I think about as far as a reflection goes, a reflection of this, when you're graphing a quadratic, it's the entirety of it. But when you think about a reflection, the reflection of the positive square root is going to be the right-hand side of your parabola. And that is emphasized by this domain restriction. Your domain is only from 2 to infinity, so 2 to the right. So when I draw my parabola, I'm only going to use the right-hand side of the pattern. Over 1 up 1, over 2 up 4, over 3 up 9. And I'm getting these numbers from 1 squared, 2 squared, and 3 squared, just using the power of the function. Okay. But there is a vertical or horizontal stretch by a factor of 3/2. So this is 1.5. This is 3, and this is 4.5. Same numbers as the vertical, only just the opposite. So instead of horizontal or vertical. So I'm going to go right 1.5 and up 1. I'm going to go to the right 3 and up 4. So 1, 2, 3, up 1, 2, 3, 4. I'm Let me go to the right, 4.5 and up 9. So 4.5 from 2 is 6.5 and up 9. 4, 5, 6, 7, 8, 9. Okay. And then we connect. And you have your quadratic. So my final answer is this quadratic comma, x has got to be greater than or equal to, and it's right here, to the right-hand side. So, again, if I draw my diagonal, then it definitely looks like a reflection across it. So, we're good. Okay, as far as my answer goes, it asks for my transformations. It asks for the domain and range, the function, the inverse, and the transformations. And then obviously the sketch. Okay. Number 8. Again, we're starting with a square root, only this time it has a negative on the interior, so we have to remember anything in front of this, in front of the x in the interior, has to be factored out. So in fact, this is the square root of negative quantity. Factor out a negative, that becomes x minus 5, and then minus 3. So that's my original function. As far as transformations go, it is a reflection over the y. It is to the right 5, and it is down 3. So when I think about the order of the transformations that I would do, first I would start with a quadratic or a square root like that. This would have to come first, the flip over the y, so it would do that. And then I would go to the right 5, so it would be over here, and then it would be down 3. So we're looking at something like that. Okay? So I'm going to go to the right 5 and down 3. And then just when I use my pattern, instead of going to the right and up, I'm going to go to the left and up. All right? So it's left 1, up 1, because the square root of 1 is 1. The square root of 4 is 2, and the square root of 9 is 3. There are no vertical stretches or compressions, horizontal stretches or compressions, so I'm going to go left 1, up 1, left 4, up 2, 1, 2, 3, 4, up 2, and left 9, up 3. So left 9 from 5 is negative 4, and up 3 from negative 3 is 0. Okay, so this is my original function. My domain is from negative infinity up until 5. And my range is from the lowest it goes is 3. And it goes, negative 3. And it goes up to infinity. Feel free to listen to music if this is. So, negative 3, comma. Alright. Now we need to find the inverse. So, x equals the square root of negative y plus 5 minus 3. I'm going to add the 3. So add that 3 over equals the square root of negative y plus 5. And I'm going to square both sides. So I've got x plus 3 quantity squared equals negative y plus 5. I'm going to subtract the 5. X plus 3 quantity squared minus 5 equals negative y. And I'm going to divide by the negative. So that puts a negative in the front. And then that makes that positive 5. And I'm going to put the f inverse over here. Because I remember that if I start with a square root, I can only end up with half a parabola. Alright? Okay. As far as graphing my parabola, normally I would think, go to the right 3. So I got a parabola to the right 3. Flip it over the x, so now it looks like this, and then go up 5. Yeah? So this is what the full parabola would look like, but we only have half of it. So if I want to know what it is, then I'm going to use my domain and range of my original to find my domain and range of my inverse. So my domain should be from negative 3 to infinity, which means it should, wait. Oh, yeah, okay. Wait, negative 3. Oh, Jennifer. Let's just go left 3. Ridiculous. But, see, I made that mistake, but then knowing that the domain should be negative 3 to infinity, helped me realize I was wrong. So go left 3, 1, 2, 3. Normally it looks like this. Flip it over the x, so it looks like that. And then, so I should have written down left 3, flip over the x, and up 5. So up 5 puts me here. So I've got a parabola that looks like this, but my domain should only be from -3 to infinity, which means it's only the right-hand side of the parabola. Okay? And then I know my range should be -infinity up to 5, and that tracks. Okay? So I'm going to go left 3 up 5, left 3 up 5, and plot my starting point. And like I said, we're only graphing the right-hand side of the parabola. So normally a parabola is over 1, down 1, over 2, down 4, over 3, down 9. And there's no vertical stretch or compression, so it is exactly that. I guess normally it's over and up, to the right and up, but since it's reflected over the axis, to the right and down. To the right 1, down 1. To the right 2, down 4, 1, 2, 3, 4. And to the right 3, down 9. I'm at 5, so that puts me -4. And that is the reflection. So. All right, I'm going to draw my diagonal. And I'm going to check out some of my points. This is to the right, 5 and down. So 5, -3, -3, +5. 1, -1, -1, 1, 4, -2, -2, 4. Okay. So there we go. And as far as identifying the answers, it said list the transformations, the domain and the range, the domain and the range, the inverse. Oh, I forgot. There we go. Okay. The domain is from -3 to infinity, so I gotta tack that on. X has got to be greater than or equal to -3. So that is definitely part of my answer. Okay. And transformations. Okay. Number 9. So number 9 and number 10 are just write the functions given the transformations. So, okay. F of x equals. I guess I could say a different function, but whatever. 2 to the x, which means this is an exponential function. That's cool, but you just got to recognize that the interior of the function is up in the power of x, or up in the power with x. So horizontally compressed by a factor of, I'm going to put my set of parentheses, but that's the interior. And I'm going to put another set of parentheses just in case there's stuff outside the x. Yeah? Okay. So in general, if there's a horizontal compression, that goes in front of the x multiplied, but I'm going to separate it out from any kind of left or right. So horizontally compressed by a factor of 2/5 means 5/2 in the interior. Reflected over the x-axis, that's a negative on the exterior. Vertically stretched by a factor of 8, that's multiplication out front, outside. And left 4 units is in the interior with x, so left means plus, so +4. So my final answer would be, and you cannot multiply these two together because this is being raised to the power, that's not. -8 times 2 to the 5/2 x plus, and then distribute your 5/2. So 5/2 times x is 5/2 x, 5/2 times 4. 5 divided by 2 times 4 is 5 times 2, which is 10. And so that is my new function with those transformations. All right, number 10. F of x equals, I'm going to leave some space. I'm going to write a 5th root. I'm going to open a parenthesis. I'm going to open another set of parentheses, close, close. And I'm going to put an x. So that's kind of the skeleton that I'm going to fill everything else in on. So, reflected over the y, that's a negative in the interior. Vertically compressed by a factor of 4/5, that's on the exterior, that's multiplication. And it's exactly what it looks like. So the left 5 units means go plus 5 on the interior. Up 16 means plus 16 on the exterior. And horizontally stretched by a factor of 6 means horizontally stretched by a factor of 6. That means a 1/6 multiplied on the interior. So my final answer would be 4/5 times the 5th root, and I'm going to distribute my -1/6. -1/6 x, and -1/6 times 5 is -5/6. And then plus 16, and that is my function. Okay. And that is the end of that page.